Hi everyone. I just wanted to give you a little bit of background on the paper I've written for the conference in Barcelona on innovation in teaching in higher education. Uh, Contact North, which is a government agency in Ontario, came up with the great idea of sending somebody around the universities and colleges in Ontario to actually interview instructors and professors who are using technology for teaching in an innovative way. They were identified through the Centres for Teaching and Learning. And having collected nearly 100 or more cases from Ontario, they decided to extend the project. So they approached me to visit some universities and colleges in the rest of Canada. So I went and interviewed about 20 instructors in British Columbia, Quebec and the Maritime Provinces in the east of Canada. And from those case studies, I came up with some of the conclusions in the paper. But what you don't get from the paper is what the actual case studies were about. And so I'd like to just talk a little bit. I'll just give three examples of some of the cases that I came across. And the first, Sue Dawson is a professor of veterinary sciences at the University of Prince Edward Island. And for her lab classes, she would often have only one model of a part of an animal. This is a model of a dog's heart. The models are quite expensive to make. They're plastinated models. And so she decided that she would make she decided to make videos of each of these models with an explanation of the various parts of the model, parts of the organ, and she made the recordings just using her own iPhone, and then loaded them up onto the university server, and she attached to each model these QR tags so that students, when they came to the lab, they could just take a photo of the QR tag, and that would provide them with the URL for the video, and they could just download the video to get the explanation of the different parts of the organ in their own time. My next example is from Simon Fraser University in British Columbia. Professor Joan Sharp is a professor of biological sciences, and she was having trouble with students even in third year who were not able to, or not very good at doing evidence-based argumentation. She found that most of her science students expected there to be a right or wrong answer for every scientific question. So she worked with Professor John Nesbitt of the Faculty of Education at Simon Fraser University to develop a tool to improve science students' argumentation skills. In this web-based tool, which students can download as part of their course materials, you'll see that there's a question posed at the beginning: wolves should be killed to protect endangered woodland caribou in northern British Columbia and Alberta. And on the left-hand side, there are reasons for this, to support this argument, which they enter one reason in box 1 and a second reason in box 2. But underneath those two boxes, you'll see there's an evidence box where students have to put in research that supports the argument that they're making. And similarly, on the right-hand side of the screen, there are con reasons, reasons against this argument. And again, they have to put in evidence-based arguments to support the reason that they've given. When the students have completed putting in their reasons and the evidence to support their reasons, they then have to come to some kind of conclusion, some kind of summary of their decision in answer to the question. And you'll see there's a box at the bottom of the screen where the students enter their answer. What Professor Sharp found was that when students used this tool, they did much better in the end of term exams in answering questions where there were no definite right and wrong answers. My next example is from Quebec, from Université du Québec à Trois-Rivières. Now, this university is not very large. It's about 7,000 students in quite a small town in Quebec. And obviously it's going to be in French, which is a minority language in Canada, but nevertheless we chose this one because it was they were very successful MOOCs, and we thought we'd look into the reasons for this. The university did 2 MOOCs. The first one was on personal finance, and the second one was on the importance of children's play for children's development. And the significance of them was that they were very successful. They had over 7,000 students, 6,000 participants watch the personal finance one, and 4,500 participated in the childhood, in the importance of play. And the features of these MOOCs was that, first of all, there was only 5 presentations in each MOOC, and each presentation was quite short, between 7 to 10 minutes. So that was 5 sessions over 5 weeks, each of 7 to 10 minutes. They also used very high quality video, and the subject matter was kept pretty simple. There were also quizzes and materials that participants could download to accompany the MOOCs. And in the importance of play MOOC, 31% of the participants actually went on to take the certificate successfully at the end of the MOOC. Now, what these cases raised in my mind is, what do we mean by innovation in teaching in higher education? Because of the 20 projects, most of them were low cost. The MOOCs were more expensive, but most of the projects were low cost. Most of them were low tech, using things like mobile phones or posters. And to be honest, in most cases, the teaching method wasn't particularly innovative. It hadn't changed a great deal from classroom teaching. But the significant thing in nearly all the case studies was that faculty had found a use of technology that enabled them to deal with a specific teaching problem, whether it was widening access or meeting the needs of a very mixed group of students and so on. Anyway, we can discuss these matters more when we meet in Barcelona, and I look forward to seeing you all then. And until then, fins aviat.